Okay, in this last video of chapter 1, we're going to talk about some different ways that you can collect sample data. So these won't be all of the ways that people out there collect data, but these are some of the most basic ways. So we've talked about why it's important to have a random sample, and a random sample actually has a specific definition. So a sample is a random sample if it is created in such a way that the members from a population are selected so that each individual member has an equal chance of being chosen. Okay, so random has the specific definition that each individual would have the same chance of being chosen. So an example here, it says, in order to test for a gender gap in the way men and women purchase cars, a company polls exactly 750 men and 750 adult women randomly selected from adults in the United States. So here, assuming that each person in the United States had the same chance of being selected, this was a random sample. Okay, now our next definition is a simple random sample. And don't let this fool you. I know it has the word simple, but unfortunately it's not, to most people, it doesn't seem more simple than a random sample. So a sample size of size n, so n is however big your sample is, however many people you want to study, is a simple random sample if it is created in such a way so that every possible sample of size n, so every group of the number that you're choosing, has the same chance of being chosen. Okay, so here's an example. So it says, in the last election, 132,312 adults voted. You plan to conduct a post-election survey of 500 of those voters. So that's our n, the 500. You get their names and number them between 1 and the total 132,312. You use a computer to randomly generate 500 numbers between 1 and 132,312. You select voters corresponding to those numbers. So this is a simple random sample. Every group of 500 has the same chance of being chosen. Okay, so even though you're selecting them individually, there's nothing in this plan that means that some groups don't have a chance of being chosen. And here, using a random number generator or pulling things out of a hat, that's really the most basic way that you get a simple random sample. As soon as you start dividing or only selecting from certain groups, it's no longer simple random. So here's an example that's not a simple random sample. It says we randomly choose 4 statistics classes and then survey 10 groups from each class. So the reason, so here we're having, our n is 40, we're having 40 students, but some groups of 40 have no chance of being chosen. So for example, let's say even the classes had 30 students, you'd have, you'd never get the group that's 30 students from one class and then the 10 from the other 3 classes. Okay, so there's just some groups, if you put all of those students from the classes together, there would be some groups that wouldn't have a chance of being chosen in this way. So a random sample, whether it's random or simple random, is one way that we can talk about collecting data. Here are some other ways that we can talk about. So this next one is not random at all. It would just be convenience sampling. So this isn't really mathematical. It's just something that's easy. So for example, if you were doing a survey and you just ask your friends or family, Or if you're inspecting things on a manufacturing line and you sample the first 100 products made. Okay, sure, that would be a sample, but you could have a lot of bias in that sample, and it was just easy to get. It was convenient for you. Okay, another method is called systematic sampling. So this is where you pick a starting place, and then you pick every kth person. So, for example, you line up people, and this could be on a list or whatever, and you choose to call every fifth person. So depending on how many people you need or whatever, you know, what number you put there for the kth would change, but you're using that same number and just going down the line and choosing that person. Okay. Now the next two are going to seem similar. So this is where you're going to want to be careful about choosing between them. So the next one we're going to talk about is cluster sample. So it says divide population into groups, select some of the groups, and use all of the members in the group. So both of these next ones, you're going to be dividing the population into groups. Here you're just picking some of the groups and sampling all the people in the group. So for both of these, let's say we're dividing people by the state they live in. Okay, so for cluster sampling, you'd say, for example, pick 5 states and survey everyone in those states. So those states are your clusters. You're getting everyone. So that might be helpful. You know, if you only have, say, 5 researchers and they need to go just to one state each, that would be one way to do it. Now the stratified sample, again, you're going to divide them into groups, but you select a sample from each group. So instead of just picking 5 states, maybe you're sampling 100 people from each state. So here you're getting some from all of the groups, but just some of the people from the groups. Okay, so we have random samples, convenience sampling, systematic sampling, cluster sampling, and stratified sampling.